There are a couple of types of graph that are made up of a number of straight lines that are studied in further maths. One of them is segment graphs and the other is step graphs. And I'll start by showing you what a segment graph is. Sometimes, especially when we're talking about the motion or the place of a certain object, we might be able to represent where it is by a straight line, followed by another straight line, followed by another straight line, and so on. And in this case, especially if we're talking about motion, there are a few different ideas that we want to keep in mind. Normally, if we're talking about motion, my explanatory variable will be time, and quite often my response variable will be distance. If we had a graph like this, there are a few points we might want to make. First of all, each segment has its own equation. And you can find the equation by looking at the endpoints of each segment and then calculating what the straight line is between those points. So you might have point A here, B, C, and D on the x-axis. So therefore this point here would be A and something. And this point here would be B and something. And you can find the equation of a straight line between these points A and B and represent that as part of the equation. Something else that's worth noting is when we have a horizontal section, that means that whatever we're measuring here is constant. And therefore, if we have something like the distance it is from a certain object, constant distance would mean that it's not moving at all. So we'll just note that down. Something else we might want to keep in mind are the points, for example, here, where it's very, very steep. The steeper that a distance time graph is, means that it's moving faster. So, the steeper means that it's moving faster. And finally, you might want to keep in mind that if something is going up, then it's moving in one direction, and if it's coming back down, then it's moving in the other direction, as we read the graph from left to right. So this graph might represent the movement of an object that leaves a certain place, let's call it the base, and travels at a relatively fast speed away. Then at this point here, the point where we've got A as the x coordinate, it continues moving away, but it slows down significantly. At the point B, it stops. And then at the point C, it quickly returns back to base, which is point D. This is how we use a segment graph, and that's the way you might want to read it. Step graphs are made out of a collection of horizontal lines. So a step graph might look something like this. Step graphs often measure the price of something. For example, if my response variable is something like dollars, and let's imagine my explanatory variable was weight, this could model the price that it costs to send an item in the post. For example, anything between 0 and, for argument's sake, 100 grams might cost a certain price, and then anything between 100 and 500 grams might cost another price, and so on. And on the y-axis, on this vertical axis, would be the different prices. Let's imagine this is $3, this is $7, this is $12, and so on. With this type of graph, we also have the point where exactly at, for example, 100 grams, we're not sure whether we should have this line here or this line here, the $3 line or the $7 line. If the $3 line's included for that point, you'll see a filled-in gap, a filled-in circle. then the respective $7 line will have an open circle. So something like this would tell me that for my sending the post item, anything between 100 grams and 500 grams is $7, but that doesn't include if it weighs exactly 100 grams when it's $3, or exactly 500 grams when this closed dot tells us that it's $12. So we need to remember, an open dot means not including, and a closed dot means it is including. We need to remember as well, we can only have one open and one dot closed at any of these endpoints. Otherwise, it won't make sense. The third thing is the way this equation is written, you'll have something like the function of cost will equal, and then we do one of these cool curly brackets, and then start talking about where these lines exist. Now, I'm going to put an open circle there. So for this function, it would look something like $3 when X is less than 100 grams. And you might want to say between 0 and 100 grams, and then that closed dot tells us that it needs to include 100 grams. $7 when X is from 100 grams, not including 100, to 500 grams. And finally, $12 when X is greater than 500 grams. And we can see the closed dot tells it that it's including as well. So that's how a step graph works. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.